Hello, my secondary math 1 class. We are going to continue talking about slope, but we're kind of going to bring in a past concept a little bit. Okay, so a few units ago we talked about graphing equations when they were in slope-intercept form. So you should kind of be familiar with this term right here. Okay, so today we're going to introduce taking them from standard form. So we're going to see them written a little bit differently, and we're going to rewrite them so they are in slope-intercept form. Okay, before we do that, I want to review or practice some more of finding the slope when given 2 coordinate points. Okay, so what we want to do is we want to write down our slope formula. So our slope formula, y2 minus y1 over x2 minus x1. Okay, so that is our slope formula. So we're going to use that formula to find the slope. Okay, so if we're just looking at number 1, we know that here we have, if they're always listed, x comma y and x comma y, and this is our first coordinate point, then this is going to be x1 and y1, and this is our second coordinate point, that'll be x2 and y2. Okay, so now that we have labeled these guys, let's go ahead and plug them into our formula. So I'm going to rewrite the formula. I'm just not going to write y2, y1, x2, and x1. I'm just going to put little blank spaces. So y2 minus y1 over x2 minus x1. And we're going to figure out what this is. Okay, so first we need the y's on top. So I have y2 spot right here. So that is lined up with 5. So I'm going to put 5 right here. Okay, minus my y1, which is -4. Okay, and on bottom I have my x's, which x2 comes first, so 9. Subtract x1 is 3. Okay, so let's solve. So we have 5 minus a -4 on top. Okay, what happens to this double negative here? Turns into an addition. So now we have 5 plus 4 on top, which is going to give me 9. Okay, on bottom we have 9 minus 3, which we know 9 minus 3 is just 6. Okay, and the last thing we need to do is see if anything reduces. So we know that 3 actually goes into 9 and 6. So I'm going to divide both of these guys by 3. Okay, 9 divided by 3 is 3. And 6 divided by 3 is 2. So we know that the final slope for number 1 is 3 over 2. Okay, let's look at number 2. So again, I want to label my x1, y1 and x2, y2. So I know exactly what I need to plug into my formula. So I have y2 minus y1 on top, x2 minus x1 on bottom, and we're going to plug in and solve. Okay, so we have y2 comes first, so we have 9 right here, minus our y1, which is -3. Okay, on bottom we have x2, which is -19, and x1, which is 14. Okay, so let's solve. Solve for the top one first. So we have 9 minus -3. Okay, what happens with this double negative? Turns into a positive. So we have 9 plus 3, which is going to give me 12. I had to think about that for a second. 12. Now on bottom, I have -19, so I'm already in the negatives, and I'm getting more negative. I'm subtracting 14 more. Okay, if you need to use a calculator, you can. -19 minus 14 more is going to give me -19 minus 14, -33. Okay, and there's no numbers that go into both 12 and 33, so our final slope is 12 over 33, -33. Okay. So that was finding our slope when given 2 coordinate points. Okay, well let's look at numbers 3 and 4. So it's asking us to find the slope of each line. So we're still trying to find the slope, but it didn't give us 2 coordinate points. It actually gave us an equation. Okay, well this equation is in slope intercept form, which we're going to talk more about today. Okay, well, slope intercept form is always written as y equals mx plus b. Okay, put a star by that, it's super important. Okay, and what do these letters mean? Well, our slope, which we're looking for, is always in front of our x. Okay, that b on the end, that's always our y-intercept. So if it's asking us to find the slope, what is the number that is right in front of the x for number 3? Okay, you might not see it. It's actually a -1. So our slope for number 3 is -1. Okay, what about number 4? Okay, our slope for number 4 is also a -1. Okay, so we know that our slope is always the number that is right in front of our x. Okay, on 3 and 4, they were actually both -1. Okay, so let's look at number 5. Now, getting a little more practice with slope-intercept form, it's asking us to write the slope-intercept form of the equation. Okay, it gives us our slope, and it gives us our y-intercept. So let's look back up here at our equation. Well, our slope always comes first. It's followed by its x, and then the b is our y-intercept. Okay, so one thing we can always write, let's start with y equals, and x is always going to be there, and then a plus is always going to be there. Well, sometimes. We'll actually talk about that more in a second. Okay, so we have a couple spaces to fill in. Our first space is our slope. Okay, in fact, I'll put a little spaces. Okay, so our first blank space is our slope. So what is our slope that it gives us? 7/3. Okay, so we filled in our slope, and what is our y-intercept? 5. Okay, so if you wanted to rewrite this, make it look a little prettier, we could rewrite it as y equals 7/3x plus 5. Basically just took away the parentheses. Okay, and that is our final linear equation in slope-intercept form. Okay, let's look at 6. So let's do our y equals, we need a space in front of our x for our slope, plus our y-intercept in the back. Okay, well, let's fill in our first space. What is our slope? What does it tell us our slope is? -7/4. Okay, right there. And what does it tell us our y-intercept is? -3. Okay, well, if we wanted to rewrite this to make it look pretty, we would rewrite it as y equals -7/4x. And since there are two signs that are different here, a plus and then a minus, it actually turns into the -3. And there is our linear equation in slope-intercept form. Okay. Awesome. Let's look at numbers 7 through 10. Okay, so numbers 7 through 10, it's asking us to write the slope-intercept form of the equation of each line. Okay, our slope-intercept form always starts with y equals. Okay, the y is always by itself. We'll look at 7 through 10. Okay, we have things that are on the same side as our y. Okay, that means we need to move them to the other side of our equal sign. Okay, so let's take a look at number 7 first. Okay, so what is the only thing you see that is on the same side as my y? Okay, so if we're looking at this side, what's the only other thing? It's this x. Okay, so when we have a positive x, what is the opposite, or how do we move a positive x? What's the opposite of positive x? It's going to be a negative x. Okay, that cancels it out, and it moves it over here. Okay, so now we have our y equals, okay, because y is all by itself, and we always want to write our x first. So I'm going to put my negative x, that came down, negative x, and it's positive 3, so plus 3. Okay, in fact, let's make that note on our paper. Always write the x term, so this time it was negative x, term first. Okay, because that's how it wants it in our equation, right? So look back up here. It always wants the term with our x to come before the term that's just a constant. That's just a number. Okay, so we got that. We wrote down that note. Perfect. Okay, let's look at number 8. Okay, what is the only thing that's on the same side as my y? Okay, there's actually two things. Okay, I see a 6x and I see a negative sign. Okay, well, let's look at what's farthest away from our y first. It's this 6x. Okay, a positive 6x. We're going to move this whole piece over. So what is the opposite of a positive 6x? It's going to be a negative 6x. That cancels it out, moves it over there. So now what we have left, we have negative y that was still over there, equals, let's write our our x term first, so negative 6x with a positive 7. Okay, now look at my y. Is my y all by itself? No, it is not. We still have this negative sign to get rid of, which technically is a negative 1 that's being multiplied to the y. So what is the opposite of times by negative 1? What's the opposite of multiply by negative 1? We're going to divide by negative 1. That gives me my y all by itself over here. Okay, divide by negative 1 and divide by negative 1. We must divide to everything on that side. Okay, well, we know that negative divided by a negative is just a positive, and 6x divided by 1 is just 6x. So positive 6x. Okay, and then positive 7 divided by a negative 1, positive divided by a negative turns to a negative. 7 divided by 1 is just 7. And there we go. Forgot to box this one over here. Okay, awesome. We got number 8. Beautiful. Okay, let's do number 9. Okay, so what is on the same side as my y? Okay, I see this 10x that we need to move. Well, it's a positive 10x, so how am I going to move, or what is the opposite of positive 10x? It's going to be a negative 10x. Okay, that cancels it out and moves it over here. Okay, so we have our y that's left over, and it's a positive y, so we don't need to get rid of any negative signs. Okay, write your x term first, so negative 10x, and bring your negative 7 down. And there we go. The only thing we had to move for number 9 was that 10x, which then turned to a negative 10x on that side. Okay. Number 10. What is the only thing or only couple things on the same side as my y? Okay, let's look at the 6x first. What is the opposite of a positive 6x? It's going to be negative 6x, cancels it out, puts it over here. So we have negative y still left over, equals, write your x term first, negative 6x, and it's a positive 2, so plus 2. Okay, we're not quite done because we still have this negative sign with our y. Okay, and we know that that technically means negative 1 times by y. Well, what is the opposite of times by -1? It's going to be divide by -1. Okay, that cancels it out. We got to do it to both terms over here. So we're just left with y all by itself. Negative divided by a negative is a positive, so those cancel out. 6x divided by 1 is just 6x. And a positive 2 divided by a -1 is -2. And there we go. Okay, those are your notes for today. There will be a corresponding assignment that you will do on Canvas.